were one time around the circle, so I was finding them after I went around the circle one time, right? So the 5 pi over 6 needs to be one time around the circle and then some more. So in order to get this 5 pi over 6, I need to go one full time around the circle and then go to my 5 pi over 6. So I have to go around my circle, then go to this point. So to calculate that, I can do this. So that would be 12 pi over 6, right? So 17 pi over 6. Okay, so let's try another one. Okay, negative 3 pi and negative 4 pi. So, going around the circle backwards one time would be negative 2 pi, right? And then this would be negative 3 pi. So what I'm doing is I'm looking in this area. This would be in between negative 3 pi and negative 4 pi. Okay, in between here and here, I want to find where cosine is equal to negative square root of 2 over 2. So that would be right here. That would be negative how much? Negative 5 pi over 4, because I'm going around backwards. Since I'm going around backwards, because I'm doing negatives, right? So I'm going around backwards. So this would be negative pi over 4, negative 3 pi over 4, negative 5 pi over 4. So negative 5 pi over 4. Now, to get there, I had to go around the circle one full time, right? In the negative direction. So I need to subtract off one negative circle. I'm subtracting it because I went around the negative time. I could, but if I went around more times, I would just keep subtracting off however many I did. Because how many times did I have to go around the circle? Full times in order to get to just one full time around the circle, which is just 2 pi. So it'd be negative 5 pi over 4 minus 8 pi over 4. Now you could, if you wanted to, and maybe this is what you're asking, since this is in between negative 3 pi and negative 4 pi, how far is this from negative 3 pi? It's 1/4. So I could take negative 3 pi over, or negative 3 pi and just subtract another pi over 4. I could do it that way also. Because I'm just going, after the negative 3 pi, I'm just going another pi over 4. I could do it that way. So that would be negative 12 pi over 4 minus pi over 4, which would still get me the same answer. It really doesn't matter, as long as whatever makes the best sense, which for some of you it's just going to take some trying it on your own and some practice to make it make sense. Okay, we're running out of time. We still have more examples. Okay, calculators. Just want to make sure that you can use your buttons okay. No issues there, so I'm going to put these up real quick. I'm going to do these in radians, so make sure your mode is set to radians. So this one should be 1.41. This one should be 0.20. That's funny. And this one should be no solution. Yes. I did number 14 on purpose. Why is number 14? You should be able to tell it's no solution without doing anything. Why is it no solution?
Because it's not in the area of the cosine.
Why, or what is the largest value that cosine can be? 1. You're right. Cosine, the largest value cosine or sine can be is 1. I put a number inside of that that's bigger than 1. So it cannot work. Tangent can go up to infinity or go down to negative infinity, so that one's fine. But cosine and sine, remember whenever you were graphing them, they only go up to 1 or down to negative 1 unless I put an amplitude in front of them. So I put a number inside of it that was bigger than 1, so I'm going to get a no solution. So if you want to, try putting that in your calculator so you can see what happens.
So tan and sine go past 1? Or they don't?
No, sine won't. Tangent will. Tangent's fine. Tangent will work no matter what. Okay, compositions. These are inverses. What happens when you take a square root of a square? They cancel out. What happens if you take a log of an exponential with the same bases? They cancel out. So what happens if you take the tangent of an inverse tangent? They cancel out. Tangent of an arctangent cancel each other out. So what is arc sine of a sine going to do? Cosine of an arc cosine. I always love this one. Is 3 pi over 4 inside the range of arc sine? No. Whenever I do sine of 3 pi over 4, what am I going to get for an answer? Yes, you do. Don't give me questions looks. Sine of 3 pi over 4 is square root of 2 over 2. Okay, what is arc sine of square root of 2 over 2? Well, arc sine of square root of 2 over 2 cannot give me this. Arc sine of square root of 2 over 2 has to give me pi over 4. So you have to be a little bit careful. They cannot fully cancel each other out because arc sine is only defined over here. So it can only cancel out fully if you're dealing over here. If you end up with something over here, it's going to sort of cancel out, but it's going to translate it back over here. So be careful of that. You know, everything has its little things, just like square root and square. Square root isn't a full function because they have to cut half of it off. They cut the negative part off. Okay, these are the fun ones. I know, we're running to the end. I'm sorry. Okay, what happens if they are not the same? If I put a sine or arc cosine inside of a sine? You know, just to be a jerk. That means you draw a triangle. Okay, arc cosine. Cosine means which two sides? Adjacent and hypotenuse. So, arc cosine gives you the angle based on this side. So, what this says, this returns this. That's what arc cosine gives you. Arc cosine of 3/5 equals theta. Arc cosine of 3/5 equals theta in this triangle. I don't care what theta is. Yeah, it just equals the angle of this triangle. I don't care what the angle is because I'm just going to take sine of the angle. Well, what is the other side of this triangle? 4. If you don't know how I got 4, you do this. And ... you end up with 4. So, what is sine of theta? So, I don't care what theta is. We never care because we're just using it to get to the end answer. That's it. That's how you do those kind of problems. And then number 20 is a harder version of that. Because on number 20, again, sine inverse of 2x over 5 is equal to what? What is this equal to? Theta. Okay, so 2x is going to be over here. 5 is going to be here. So what is my adjacent side? Oops. Yeah. So you put in Pythagorean theorem, you're going to get that. That's A. You use this a lot in calculus. I find A using Pythagorean theorem. I just put the x's in there. It's fine. So then tangent is opposite over adjacent. So tangent is going to be 2x over square root of 25 minus 4x squared. It's fine. Leave it. It's a lot harder to rationalize than we need to deal with. Nope. You can't simplify that over a minus sign. Okay. Okay, at this point, and based on what I've seen turned in so far, I'm going to assume you guys don't need a review assignment. So then the next 2 days are going to be time to work in class.
Oh, I need to turn in